That tiny wheel is attached to a 185-foot bomber. It is not there by accident, and it is not the B-52's main landing gear. It is the visible clue to two unusual pieces of engineering. A wing designed to flex through a 34-foot arc, and a landing gear system that can point down the runway while the aircraft itself points somewhere else. Watch the real aircraft closely, because each strange-looking part solves a different problem. Start with the wing. From the fuselage to each tip, it stretches more than 90 feet. A structure that long cannot remain perfectly rigid without becoming extremely heavy. The B-52 uses a flexible wing instead. An official Air Force description says the tip can move through a 34-foot arc. With fuel loading the wing on the ground, the tip can sit about 12 feet below its level position. Under flight loads, it can rise about 22 feet above level. That movement looks alarming only if you expect the wing to behave like a concrete beam. Flexing spreads changing loads instead of forcing every gust and turn into a rigid joint. On this aircraft, visible movement is part of the design. The flexible wing creates a ground problem. When the aircraft is parked or taxiing with fuel in the wings, those long tips droop close to the pavement. That is why the small wheel sits near each wingtip. The Air Force calls it wingtip or outrigger gear. On the ground it can bear weight and keep the wing from contacting the runway. During flight it retracts into the wing, because the airflow and lift move the tip away from the ground. So the wheel is not trying to support the entire bomber. It stabilizes and protects the flexible outer wing when the geometry is most extreme. Once you know that, the wheel stops looking improvised. It becomes a scale marker for how much the wing changes shape. Now look under the fuselage. A conventional airplane normally has two main gear assemblies spread apart, plus nose gear. The B-52 uses something very different. 4 dual-wheel main gear units arranged in a line beneath the fuselage, with the 2 wingtip outriggers providing lateral stability. This arrangement is called quadricycle landing gear. It keeps the heavy main loads close to the center of the aircraft instead of placing large landing gear structures out in the flexible wings. The result explains the aircraft's stance. The body carries the primary load. The little wheels at the tips stop the enormous wings from tipping or scraping. One system handles weight, the other manages span and flex. The strangest trick appears in a crosswind. An aircraft may need to point its nose into the wind while its actual path stays aligned with the runway. That is called crabbing. Landing in that attitude would normally twist the tires sideways at touchdown. On the B-52, all 4 main gear units can swivel. The crew aligns the wheels with the runway while the fuselage remains angled into the wind. From the ground, the bomber can appear to approach sideways even though the tires are prepared to roll straight. The Air Force designed and tested that capability because a 185-foot wingspan leaves little room for casual corrections near the runway. The landing gear is not merely retractable support. It is part of the crosswind control solution. Now replay the first shot. The tiny wheel tells you the outer wing can droop under fuel load. The 4 main bogies tell you the fuselage carries the heavy landing loads. Their swivel tells you the aircraft can keep a crab angle without forcing its tires to skid sideways. One odd detail reveals the whole design. Flexible wings, central landing gear, and a bomber built to manage crosswinds at enormous scale. The next time a machine looks strange, do not ask why the designers made it normal. Ask which problem forced it to be different. This is why it spiked. Real footage, hidden mechanisms, and the clue most people miss. Subscribe for the next one.